A wet market is a marketplace selling fresh meat, fish, produce, and other consumption-oriented perishable goods in a non-supermarket setting, as distinguished from dry markets that sell durable goods such as fabrics and electronics.
Biowaste generated from the food industry, slaughterhouses, and wet markets are from a broad spectrum and are derived from different stages of food processing, and the waste are classified into solid waste and wastewater. The abattoirs, wastewater, and solid waste are directly disposed into water bodies and lands and adjacent to the abattoirs, creating pollution problems. This is due to inadequate waste management and treatment facilities.
The chemical contents of wastewater from slaughterhouse are almost similar to municipal sewage. This induces algal blooms that limit oxygen supply for the aquatic life and cause microbiological contamination of water bodies. Hence, the application of the astonishing volume and wide range of HH biowaste disposed into the ecological system from slaughterhouse and wet market should not be discarded.
The waste products of shellfish are shells and viscera. The inedible portions of some demersal species and shellfish are usually discarded. However, aquatic waste are considered valuable byproducts that are recyclable as fertilizers, animal feed, dietetic products, natural colorings, biodiesel, and enzymes. In addition, every 1,000 of kilogram of fish production during skinning and canning generated 15 to 17 liters of wastewater. And this effluent consists of feces, antibiotics, fish feed, a component that are rich in protein and can be post-processed to be used as animal feed or manure. However, effluents from the fish processing industry are often released directly into the shallow coastal water, leaving impacts on the aquatic environment.
Current biowaste segregation processes associated with the segregation of liquid and solid waste are known as feedstock technologies. Segregation processes are key for reducing the health risks of slaughterhouse and wet market waste and minimizing the survivability of infectious agents, where the solids in wastewater contribute effectively to the colonization of microbes. After segregation, the solid waste from slaughterhouses and wet markets are collected and stored in a refuse room not exceeding 24 hours to minimize the growth of fungi and bacteria. Solid waste separated during different processes are skin trimmings, meat trimmings, dung, and grommets. Biowaste management technologies have evolved greatly from simple processes to the most efficient and high-end processes, which can be classified into four categories which are directly of the biowaste generate: biological processes, physical chemical processes, and thermochemical processes. Currently, biological and thermochemical processes have gained tremendous attention from industry because these processes could be recycle large amounts of biowaste in a short period of time.
The composting technique, on the other hand, is a common method to treat different waste such as manure, litter, and feather from slaughtering activities and recycle them into valuable bioproduct. Large-scale poultry slaughterhouse waste are mixed in different ratio with bulking agents such as cardboard, agricultural waste, or sewage waste. The main product of composting process are fully mineralized materials such as CO2, H2O, NH4 plus stabilized organic matter heavily populate with competitive microbial biomasses and ash. Based on the facility requirements and energy consumption, composting treatments can have a higher impact as compared with other treatments. because composting may reduce the weight and the volume as slaughterhouse and wet market biowaste dump into landfills and reduce pathogenic microorganisms into the soil, and the nutrient conversion from the waste can enhance soil properties.
Incineration is the most effective method among all treatments, as it will kill all infectious agents that may present risk to human health and the environment. Nevertheless, the downsides of the incineration method are the relatively slow process, higher cost, and stringent place code criteria and capacity that the process is conducted in one facility. The pyrolysis technique often produces greenhouse gases such as carbon monoxide and nitrogen. Comparatively, incineration produces carbon dioxide, oxygen, nitrogen, water, slag, and ash.
Advanced biowaste recycling techniques are ideal for waste management, as this will reduce the threats to the public, such as spread of diseases, foul odors, and olfactory nuisance, and for the environment, air, water, and groundwater pollution. Additionally, biowaste recycling processes have evolved greatly due to the increasing demand for biowaste byproducts and also due to limited landfills. The development of biowaste byproducts can shift the economic paradigm toward a circular economy, which focuses on the recovery of resources and turning them back into valuable byproducts for commercialization. Thus, biowaste recycling technologies provide future opportunities for economic growth, as the technologies can act as a driving force for biowaste management business development. The recovery of nutrient sources, such as phosphorus and nitrogen, from biowaste recycling is a good opportunity for waste-to-wealth product development, thus provides financial stability for biowaste businesses. The market demand for biowaste recycling technologies will rise as demand increases for waste products, such as stock feed and fertilizers from animal biowaste, and also bioenergy as an alternative source of energy.